Okay, Assalamualaikum class. So let's see some example on the diode DC analysis. Okay, for the first question, where you're going to have, the question will ask you what will be the value of ID and VD. So first of all, what you need to do is you need to complete the whole circuit. So here will become plus minus, here become 5. So since this circuit you have two supply, so you need to connect here to since this minus 5, so become minus, plus, minus, plus, and what you need to write here is only 5. Then we connect both together. This is what we call common ground. Okay, let's say this is model 1, that is V gamma is equal 0.7 volt. So how are you going to write the equation? Just use KVL, so it become minus 5 plus 20 K I plus, replace your VD with V gamma because it's PLM1, right? So plus 0.7 minus 5 will be equal to 0. Then you can get I equal 10 minus 0.7 divided by 20K, and then you can get the answer. Okay. How you can calculate the VD? So this is this I is equal to ID. So since this is only a series circuit, so the I that you calculate just now is actually ID. Now let's see your VD. VD is the voltage drop inside the diode only. So this is your VD, since it's PLM1, so you directly can get 0.7 volt. Okay. So how about question 2? Question 2 is having only one supply. So try to complete the circuit again. So it becomes 5. And then this will be your common ground. So let's see what will be the value of your I. So again, KVL minus 5 plus 20K I plus, you can ignore this one because this is like a probe. So what is the voltage drop inside the diode is actually your Vgamma, right? 0.7 equal to 0. And then you can get your I equal 5 minus 0.7 divided by 20K. The current will be always in milliampere. Okay. Now let's look at your V out. Now it's the say VD is saying V out. So imagine your V out is like you measure using your multimeter. So the V out point is between this plus and the common ground. So what will be your V out? V out is actually your V gamma, right? Because this is only inside the diode. That is 0.7 volt. So is this I is actually the ID? Yes. And then you can solve the question. Okay. Hint number 1, always complete the loop. Okay, let's see the third question. Again here, this question is having two supplies. So what you need to do, again, complete the whole circuit. So it become 5. See, this is minus 5. So become minus plus, negative plus. And where is your common ground? So this will be your common ground. So this will be divided by 5 because you already draw here minus. So let's say this question is V gamma, the PLM1. We say V gamma is equal 0.7 volt. So the KVL equation says minus 5 plus 20 Ki plus. No, you need to replace your diode with the PLM1. So it becomes V gamma 0.7 plus. You can ignore this one because it's a probe. So plus 20 Ki minus 5 equal to 0, and then you can get your I. Okay, second question is the voltage. So what is maybe the voltage at the diode V out here? So let's see where is the V out is probe. So V out is probe is after the diode until the common ground. So we make the KVL equation again. So it becomes minus 5 plus 20 Ki. So this between these two here is actually V out plus V out equal to 0. Because between this point until this point, you can consider the whole here is actually V out. So if you compare the above equation, what is your V out actually? V out is this whole, right? So then you can calculate your V out is actually 5 minus 20 Ki, and then you can get your V out. Okay, so for this question also will be the same. You can try by yourselves. But let's look at the question number 5. Question number 5 says that we have two supply plus and minus. Okay, before you actually start to solve this circuit, you need to look at your diode whether this is turned on or off. So if you look at the previous question, question number 3, here is plus, right? And in order for the diode to turn on, you need to have here plus and minus. So this one is okay. Is the diode turned on here? Yes. But how about here? Since the plus is connected to at the negative and the negative is connected to the plus. What will happen to the diode? The diode will be turned off. Okay. So now let's redraw the circuit. So here you have plus 5. Turn off means open circuit. And here is your V out. This is 20K. And then here is your minus 5. So the question say what will be the current flow here? So there will be no current, right? So I equal to 0. But will your V out also will be 0? Since this no, because the circuit is having minus 5 here. So the voltage probe is from plus until minus 5. So how you can find the V out? So you can have the equation from here to here. So let's say the equation is minus V out plus 20 Ki minus 5 equal to 0. But what will be the current? There will be no current, right? So you can get your V out is actually minus 5 volt because it is still connected to the negative power supply. Okay. Okay, how about for question number 6? So same like just now, it's already now in a complete circuit. So you just draw the KVL. Minus 5 plus 4.7 Ki. Let's say your Vgamma here is 0.7 again. So plus 0.7 plus V will be equal to 0. Then it will be like maybe this question is 1 volt. So you can get the I here directly. Okay. But what will be your VD? VD is only the voltage drop across the diode. So this will be 0.7 volt. Okay, so let's try to solve this question. So again, this question is not a complete circuit. So first of all, you need to complete the circuit. So here will be 9 volt plus minus. And then you have a 10K in series with the 9 volt. And then you have here 20K. And then you have a diode. So the diode here is Vgamma is 0.6 volt. So just replace here become 0.6. And then you have here 20K. And this will be your V out. All are connected to ground. Okay. So how are you going to solve this question? So it depends on any concept that you learn inside the electric circuits. So let's say we use mesh. So here will be I1. Here will be I2. So what will be the loop equation at loop number 1? So it will become minus 9 plus 10K I1 plus 20K I1 minus I2 equal to 0. So this will be equation number 1. Loop number 2. So 20K I2 minus I1 plus 0.6. Why plus? Because this is a diode is on, right? Plus 20K I2 equal to 0. So this will be equation number 2. So you try, I believe that you know how to solve this one. You have 2 equation and 2 unknown. So you can get the value of I1 and I2 as shown here. Okay. So the I here is the current across the diode. So I, is it I1 or I2? So I is actually I2. So you can get here 0.2025 milliampere. And how about the voltage? So V equal Ohm's law, right? V equal I to R because this is I is actually the same with I2. So you just multiply 0.25 milliampere multiplied by 20K and then you can get 4.05 volt. Okay. So this is how you're going to solve. So just hold the principle of the either mesh or nodal to solve this question. When you need to check your diode, is it turned on? So if this turned on, you can replace with depend on the question. Okay. See the second question. So this is the question number 9. So again, you have a diode over here. So if you redraw the circuit, so here will be 2 volt. You have 5K. Here is 3K. You are going to replace your diode with 0.45. So this is turned on diode because current go to the positive. So this is 0.45 volt. Okay. So how are you going to solve this question? You can use any concept that you have learned. So let's try again mesh analysis. So again, here is I1, here is I2. So at I1, so it become mesh number 1, so become minus 2 plus 5K I1 plus 3K I1 minus I2 equal to 0, equation number 1. So you can get here 8K I1 minus 3K I2 equal to 2. Okay. Loop number 2 is 3K I2 minus I1 plus 0.45 equal to 0. And then you can get here minus 3K I1 plus 3K I2 equal minus 0.45. This will be equation number 2. So by combining these two equations, two unknown, you can get your I1 equal 0.31 milliampere. Your I2 is actually 0.16 milliampere. Okay, so let's see, go back to the question. The question want ID and VD, right? So what will be your ID is the current across I2, that is 0.16 milliampere. Okay. What is your VD? VD is the voltage drop across the diode, that is 0.45 volt. So there are many ways to solve this question. Another concept here is the voltage drop here is 0.5. So you can denote, because this is parallel, right? So the voltage drop here is also 0.45. How you can get the current across this resistor? The current across this resistor is IR2 equal 0.45 divided by 3K. So here is you can get 0.15 milliampere. So this will be the current IR2. So what will be the current here is IR1. So what will be IR1 is equal to minus 0.45 divided by 5K. So here you can get 0.31 milliampere. Okay. How you can get ID? So ID use KCL equation. Current entering is equal IR1. Current limit equal IR2 plus ID. So you can get your ID is equal IR1 minus IR2. That is 0.31 minus 0.10. You can get 0.16 milliampere. So there are many ways to solve this question as long as you can get ID and VD. So please try by yourself to solve this. So how are you going to solve this one? Again, you always complete the loop. So you become 10. And then here will become minus plus. This will be your common ground. So it's 5 and 10. So you're going to replace this with 0.7 because this is turned on circuit. So just draw the loop here. So try by yourself to solve this question. Okay. And the last question is about the load line. So when talking about load line, you are given the graph. And in this question, it gives the Q point, ID, and VD. So remember, when you are going to solve this question, you need to have what equal y equal mx plus c. Y is your ID, m is your VD plus c. Try to get the KVL from these circuits and then try to solve it accordingly. So we will discuss this question in the next class. So I hope you can try this question by yourself. So that's all for today. Assalamualaikum warahmatullahi wabarakatuh.